Okay, section 6.5 is properties of logarithms. You know that the logarithmic function with base b is the inverse of the exponential function with base b. Because of this relationship, it makes sense that the logarithms have properties similar to the properties of exponents. So the properties of exponents say let b, m, and n be positive real numbers with b not equal to 1. So the product property, it says if I have two numbers like m, and I'm multiplying them, I can separate them and add them. So remember, when we're doing exponents, if the bases are the same, then we add the exponents. So we're kind of doing the same thing here, because remember, our base is b. Same thing with the quotient, okay? Remember, with the exponents, if the bases were the same, then we could subtract them. Well, we're doing the same thing here. And then with the power property, again, a power raised to a power. Well, this time, again, we would multiply them, and that's kind of what we're doing here. We're multiplying the n by the log of m, all right? So now, they have a couple little special ones that they're asking you to do. So example 1, use log to the base 3 of 4 is equal to 1.262, and log to the base 3 of 5 is equal to 1.465 to evaluate each logarithm. So on the first one, log to the base 3 of 4 over 5, that's going to use the quotient property. So we're going to be able to say that the log of 3 of 4 minus the log 3 of 5. What they just told us up above was that's 1.262 minus 1.465. And if we add those together, we'll get negative 0.203. Log the base of 20. Now look, they're asking us to put it with 4 and 5. So what do you know? What times what would equal 20? All right. So if you think about that one there, okay, you would tell me it's equal to log the base 3 of 4 times 5. And if we do that, we'll find that since it's multiplying, it's the product, we would say it's the log the base 3 of 4 plus log the base 3 of 5. And again, with that, we'll get 1.262 plus 1.465. And when we add those up, we'll get 2.727. And then the last one, again, you could say it's the log to the base 5 times 5. But again, what they're trying to show you is one of each kind. So on this one here, you could rewrite it as log to the base 3 of 5 squared, because you know that 5 times 5 is 5 squared. So if we do that, then we're going to look at the power property one, which tells us we can take this 2 and put it in front. And when I do that, I'll get 2 times 1.465. And when I multiply those out, I'll get 2.93. Okay, so you can also use the properties of logarithms to expand and condense logarithmic expressions. Again, you'll have a couple of these. So expand the natural log of 3 times x raised to the 5th power divided by y. All right, so if we're going to look at it here, all right, we have something divided by something. So we can go ahead and subtract them. So I can say that's the natural log of 3x raised to the 5th power minus the natural log of y. I have an exponent there. All right. So in that one there, I can take the natural log of 3 plus, well, I have that times first. Let's go ahead and get rid of the times first there. Plus the natural log of x to the fifth minus the natural log of y. Now, why did I do that? Okay, because some of you would have said, well, why didn't you just take the 5 down in front? Well, because the 5 is only attached to the x. It's not attached to the 3 times x. If I would have had the 3x in parentheses like that, then I would have brought it down, okay? But now I can take, and now since I have the x by itself, now I can go ahead and bring that 5 down. And that's as expanded as I can do it. I can't do anything else. So I'm done. So like we can expand it, we can also condense it. So they're going to ask us to condense this one here. All right. So now on this one here, they're kind of trying to give you a little trick here because you have 4 log 3 minus log 3. Well, if you have 4 log 3s and I take one of them away, how many are you going to have left? You're going to tell me, well, you're going to only have 3 log 3. Okay, so I'm making it smaller. That's what condense means. So now I have this log to the base 6. Now remember, I have 3 times something, so I'm going to put that 3 up here. Okay, so now I can write this as log to the 6 times 3 cubed. And finally, what is log to the 6 times 27? Because that's what 3 cubed is. And you would tell me it's log to the 162. And that's as condensed as we can make it. Okay, pretty straightforward stuff right now. Okay. Now this other one, on this one here, it says logarithms that with any other base than 10 or e can be written in terms of common or natural logs using the change of base formula. If a, b, and c are real numbers with b not equal to 1 and c not equal to 1, then log to the base c of a is just equal to, kind of look at what they're telling you, it's the common log of a over the common log of c. Remember, that's going to kind of make that be log to the base 10, right? That's what common log is. Or we can say it's the natural log of a over the natural log of c. So I know that with our calculators now, we can just plug it in to find out what the real answer is. But I know that some teachers like you to learn this, so that's why I'm going to give it to you. I know a lot of you would say, well, hey, I know I can use the log of the base 7 because now our calculators will do that, but at one time they didn't. So again, I'm just showing you to do it. So log to the base 7 of 11, okay? I can write that as a log of 11 over log of 7. And then that one there would be, if I take that and divide it, if I do the common logs in the calculator, you can just say it's 1.232. And then same thing with this one here, but I just went ahead and showed you that I'm going to just do, because I told you it could be the natural log also. So on this one here, we could also write it as the natural log of 19 over the natural log of 2. And on that one, we would get approximately 4.248. Okay, so again, all depends on your calculator, to be honest, and who your teacher is. Okay, so and finally, our last one here is a word problem. Again, we have some more word problems here than we used to. So it's important that you start doing some of them. So, for example 6, for a sound with intensity I in watts per square meter, the loudness L sub I of the sound in decibels is given by the function L sub I is equal to 10 times the common log of I over I0, where I sub 0 is the intensity of a barely audible sound, about 10 to the negative 12 watts per square meter. An artist in a recording studio turns up the volume of a track so that the intensity of the sound quadruples. By how many decimals does the loudness increase? So, what it's saying here is that if I is the original intensity, okay, then we know that 4 times I, because that's what quadruples means, 4 times I is the intensity quadrupled. Okay, so the increase in loudness is equal to L sub 4I minus L sub I. All right, so we're going to take and say we have 10. Sorry, didn't mean to do that yet. So we have 10 log of 4I over I sub 0 minus 10 to the log of I over I sub 0. Okay, so we're subtracting it. So notice I have something in common there. I have a 10 there that I can factor out. So then I would have log of 4I over I sub 0 minus log of I over I sub 0. Okay. And that will equal 10 to the log of 4 plus log of I over I sub 0 minus log of I over I sub 0. All right. So you see what's happening here? We wanted to get rid of something that we, because we don't know what I and I sub 0 is. So now notice I can get rid of those because plus I sub 0. So I have a plus and I have a minus, so they cancel each other. So what am I just left with? I'm just left with 10, the common log of 4. So again, you're going to plug that into your calculator. And when you do that, you'll get approximately 6.02. And they said it was in decibels. And that would mean that's what we would say dB is decibels. And that's it.